Have you ever just stood by a big river and felt its power? It's incredible, right? Now, what if I told you that we, as humans, figured out how to tame it? Not just stop it with a dam, but to actually steer it, to guide its flow to water our crops and supply our towns. It's an absolutely massive engineering challenge, and today, we're going to pull back the curtain on the incredible giants that make it all possible.
All right, so here's the game plan. We'll start with the big picture. What's the problem with controlling a river in the first place? Then, we'll dive into the brilliant design of a weir and its bigger, more powerful cousin, the barrage. After that, we're going to go deep, I mean literally, into how you even build these things on soft, sandy ground. And finally, we'll uncover a silent, invisible threat that's always trying to tear them down from below.
So let's start with the basic challenge. You've got this huge river flowing along, but the farms that desperately need that water are miles away and maybe a little higher up. You can't just stick a pump in the river, right? You have to fundamentally change the river's behavior. You've got to raise the water level so you can divert it into canals and send it exactly where it needs to go.
And that is the million-dollar question for civil engineers, a puzzle they've been solving for centuries. How do you build something strong enough to hold back all that water, but also smart enough to handle it, especially when a massive flood comes roaring down? Well, the first part of that answer is a surprisingly elegant piece of engineering we call a weir. So what is a weir? At its heart, it's just a low barrier, kind of like a short wall, built right across the river to raise the water level upstream. It's the go-to tool for diverting water. But of course, it's not quite that simple. Not all weirs are created equal. Let's take a look at a few of the main types. First up, you've got the classic masonry weir. I mean, this is old-school engineering at its finest. It's just a solid, heavy wall of stone or brick. It holds back the water through sheer brute force. Its own massive weight is its greatest strength. Simple but effective.
Then you have the rock-fill weir, which is a bit more clever. It's got a solid core, sure, but the bulk of it is made of compacted rock and earth. And you see those gentle slopes? That's not just for looks. That's a key design feature that calms the water down as it flows over, which really helps reduce erosion on the downstream side.
And of course, there's the modern concrete weir. This one is often built as one single seamless structure, which makes it incredibly strong and durable. But here's the really cool part. No matter what they're made of, stone, rock, or concrete, all these weirs share a set of brilliant design features that protect them from the river's constant assault.
So sitting right on top of the weir, you'll find these things called crest shutters. They're basically just adjustable gates. Most of the time, they're kept up to keep the water level high for irrigation. But let's say a big flood is on its way. Well, you can just lower them, and that creates a huge open path for all that extra water to flow over safely. It's a simple but absolutely critical safety valve.
Okay, now let's look down at the foundation. A river is always trying to carve away at its own bed. It's just what rivers do. To stop it from digging out the dirt from under the weir, engineers build this huge concrete floor called an impervious apron. You can think of it like armor for the riverbed, protecting the structure's feet from getting washed away. And at the very edges of that concrete floor, you've got cutoff walls. These are vertical barriers that are driven deep down into the riverbed. They act like giant anchors, locking the whole foundation system in place and making sure it has a solid footing to stand on.
Now, this might just be one of the most ingenious parts of the whole design. Look, water is always going to find a way to seep under the weir. It's just a fact. So instead of trying to fight it, engineers use an inverted filter to let that water escape safely. It works kind of like a coffee filter, but in reverse. You have layers of sand and gravel that let the water out, but they trap all the fine soil particles. It's a brilliant way to relieve pressure from below without the whole thing eroding from the inside out.
So a weir is great for raising the water level, but what if you need total minute-by-minute control over a really massive river? Well, that's when you bring in the big guns. That's where the barrage comes in. You can think of it as the next generation of river control technology.
So what makes a barrage so different? Well, instead of a single solid wall, it's a series of enormous piers with huge adjustable steel gates in between them. This setup gives engineers incredibly precise control over the river's flow and water level. And get this, those piers are so strong you can often build a whole highway or even a railway line right on top of them.
Now this brings us to a huge problem. A lot of the time, these massive structures have to be built on soft, shifting riverbeds, made of sand and silt, not exactly the solid rock foundation you'd want. So how on earth do you anchor something that weighs thousands of tons on ground that's basically mud?
Yeah, this is a monumental engineering problem, right? You're trying to build this mega structure that needs to be perfectly stable,
but you're building it on ground that is anything but. So, the only solution is to go deep, to use some really specialized foundations to find a solid anchor way, way down.
And for this job, engineers have two main tools in their toolbox. First, there's the well foundation, which is pretty much what it sounds like, a giant concrete cylinder that you sink deep into the earth. And for working in really deep water, they use something called a pneumatic caisson, which is this high-tech, pressurized, airtight chamber that lets construction crews work on the riverbed as if it were dry land. It's pretty wild.
The process for building a well foundation is just amazing. First, you build a temporary little dam to create a dry work area. Then, you build the first section of this huge concrete cylinder with a sharp cutting edge on the bottom. Now here's where the magic happens. Workers start digging out the dirt from inside the cylinder, and the whole thing slowly sinks under its own weight. They just keep adding new concrete sections on top and digging out from below, over and over, until it hits the right depth. Then you seal the bottom with a concrete plug, fill it with sand, and bam, you've got a rock-solid foundation.
Okay, so the structure is built, it's sitting on a super solid foundation. The battle is won, right? Not quite. There's one last enemy to fight, an enemy that's silent, invisible, and is constantly trying to destroy the structure from the bottom up. It's a phenomenon that engineers call creep.
So this invisible force is what we call uplift pressure. Just think about it for a second. The water on one side of the weir is way higher than on the other side, right? Well, that difference in height creates immense pressure, and it forces water to seep or creep through the soil underneath the structure. And as that water seeps, it pushes upwards on the foundation.
And here's why that's so dangerous. That seeping water is exerting this powerful upward force, the uplift pressure, on the entire base of the structure. If that upward push ever becomes stronger than the massive weight of the weir pushing down, the whole thing could fail, catastrophically.
So how do you stop it? Well, the solution is just beautiful in its simplicity. Sheet piles. These are long, interlocking walls of steel that are driven deep into the ground. Now, here's the clever part. They don't actually try to stop the water. Instead, they force the water to take a much, much longer journey, all the way down one side and back up the other. By making the water travel so much farther, by lengthening its creep path, they cause it to lose energy and pressure. By the time it gets to the other side, it's just too weak to do any real damage.
So, from the adjustable gates on top to the hidden steel walls underneath, every single piece of these structures is part of this incredible symphony of engineering. And it's all designed to withstand, control, and divert one of the most powerful forces on our planet. It really makes you wonder, doesn't it? As our climate changes and our need for water evolves, what will the next generation of these engineering giants even look like?